Namaskaram everyone. Welcome back to the 31st episode of our Master Unreal series. So in this episode there are three main things that we are going to do. First is how to set up your crosshair. Second is how do you aim and spawn the bullet at the correct position. Third is how does the bullet travel to the endpoint or the actor or the object that you have aimed. So all these 3 points will be covered in detail. We will take reference from Resident Evil 4 as well. We will understand how this aiming mechanics works, and I'm sure you will enjoy this tutorial and you will never ever struggle with the aiming again. And if you haven't watched the previous episode, please do check it out because I have shared the Mixamo character rigged with UE5 mannequin for free in the Discord channel. So make sure you download it, and without wasting any time, let's get started. Alright, so we are in our editor now. First we will create the crosshair for our character. So I'll go to widgets. We have these from our previous episodes. I'll create a widget blueprint. User widget WBP underscore crosshair, or you can say UI as well. Alright, now we will drag the canvas. And now we will use 3 border box. You can use any image if you want, but I'll just show you how you can do this manually as well, because pasting an image is not a big deal. So just copy paste it 3 times. You will see 3 borders. First is this one, second is this one, and third one is this. So let's arrange the order. And this one is left line. This one is the right line, and this one is the bottom line. We need one more. I'll duplicate this here and I'll change this to dot. That would be in the center. So we will align these lines and this dot relative to the center. So for this, what I'll do, I'll select all of them. I'll change their anchors to the center, and I will set the left and right offset to 0. They come in center, and the size is 0 0 as well. Now you can see it is very diminished. So I already have the value, so I'll just tell you. First we will start from bottom. It will remain in center, but the position Y we will just pull it down. So 6. We will increase the width by 5, and the size in the Y direction should be like 20. Okay, so you have in center. Now you can go for right. We can extend the size by 20 in the X and 5 in Y. Then we go for left. We'll apply the same width and the height as the right one. So this will be 20 and this would be 5. Now we need to position them. So for left, you can go for 1.45 and the Y should be 0. For right, you can shift it minus 0.45. And for the bottom, you can go for 0.47 to bring it in center at this line, and minus 0.15 to just pull it down. Okay, you have it there. Now we need a dot. So for dot, we can go for 5 by 5 size, a small square, and we'll position it in center. So 0.47. Okay, so the 0.47 seems like a precise value, and there we have it. This is our crosshair. Compile. And now we can go to our blueprints, third person character. This is what we did. What I'll do here is I'll call create widget in the event begin play. This is what we did. So in the event begin play, we would like to create the crosshair class, search for crosshair. And once this is created, this will be promoted to variable, so that we can save its instance. I'll name it WBP crosshair. Alright, now this is created, but we have to add it in the viewport. So add to viewport and we can connect this back. Okay, now if you compile and play, you have your crosshair. Now we need to position it correctly. So this is my camera. So select camera boom and reduce the length by, let's say, 150. Okay, you can go back. And now we can adjust this Y by, let's say, almost at the shoulder. Keep it 55. And we will just pull it slightly around 60 so that it is almost aligned with the shoulder, 55 and 60. Okay. Now if you compile, play, you have your crosshair aligning with your shoulder. Perfectly fine. You can move up and down to see the full body. Otherwise you will be focused. Okay. You can come out, and now in the blueprints, you can create a new folder that will store ammunition. And we will create a blueprint class, a actor, and we will call it B bullet. So this means bullet blueprint. So B stands for blueprint, and we will add the mesh of this bullet, and we will drag it on the scene root so that we can make this as our new root. Now we need the mesh. Okay, now we need the bullet mesh. So I'll open this up, I'll import, and this is the bullet FBX. I'll provide this in the description. I made it on my own, so I can share its FBX without violating any terms. Don't worry, it's just a temporary bullet for our testing purposes. We will replace it with the actual bullet. Okay, so this doesn't look at all like a bullet. First, we will add a box collider. This will detect if this particular bullet hits something or touches something. And now we will shrink this box to match with the size of bullet, because if this box touches anything, doesn't matter if your bullet touches or not, if this box touches anything, it will be considered as a hit for this bullet blueprint. So to avoid that, we will change its size to 28 and 5. This is the size of bullet that we want. I'll go to static mesh and I'll reduce it. Make sure this lock is unlocked, and then you can reduce the bullet by 0.35, 1.8 in the height. Okay, now it looks like a bullet, sort of. Now you can do mesh bullet, just rename it, save all, and now we need to create the material. So I'll go for material, bullet, matte. Open it up. Okay, let's start from the color. So right click, constant, 4 vector, and I'll choose a yellow color. So for yellow, you can write 5, 1.5. This gives you a yellow color, and then you press OK, and we'll connect it with our base color. So this is how it looks like. We just want to give a glow effect on the boundaries. So again, we will use the Fresnel node for this. Search for Fresnel, and then we would like to multiply this base color that we have created by this Fresnel, and then we'll connect it here. Okay, now you got this kind of effect. Now we need to adjust these values. So one way is you hardcode them. Another way is you promote them to parameter. It is similar to blueprints where we promote two variables. This in material editor, it is parameter, and we can set the value 2 and 0.02. So if you want to do it on your own, then you have to test a lot, or you have to take a reference. So I'll just share the values. Now we have this glow, but we want it to be little emissive as well. Now we change this blend mode to translucent to get this, and this gives you the option of opacity, so you can plug the Fresnel here. Now you have this glowing effect. Now if you hit save, and now what I want you to do is right click and create material instance. Once you have it, open it up, and now you can expand these and you can enable them and change them to 3.13. And we need to add a bit of a glow. So for adding a glow, we will plug the value in emissive color. So I'll just bring this out and I'll multiply it. Remember, multiplying anything increases its brightness a bit. So this is the Fresnel effect color that we have got. We just want to make it glow, so I'll just multiply it with the value. So I'll promote this to a parameter and I'll say emissive color, and you can save it. And then in the instance, you will see this parameter. Just enable it and make it 40. Now you see it's glowing. All right, remember you can add a glow effect in different type of actors. So instead of creating material for each of them, you just create the material with these variables, and then you create instance for each object. Now you can say that rifle bullet will have less glow than handgun ammo, or the shotgun ammo will have more glow. You can just create a single material and then create instance from it with different values for different situations or use cases. So I'll go in the bullet and I'll select this bullet matte instance and I'll plug it here. You can see now this gives a glowing effect to our bullet. So compile and save. Okay, now the next thing we want is to spawn this bullet when we press on fire. So for this, first we will create an input action. You can duplicate this crutch. So press Ctrl D, IA fire, and save it. Make sure that start is gone, and then go back. In the IMC default, this is your controller where all the mappings are present. You can add a new mapping. Scroll down all the way to the bottom. Select this fire action that you created and expand it, assign it a key. Press on this keyboard and press again, left click. So this assigns the left mouse button for this action. Save it. Go to the third person under event graph, or you can create a new graph for this, call it weapon graph. Open it up. You can go in the actions, drag it out, so you have your fire event here. So you can go to event graph, find the event tick. Okay, those of you who are following the series, in the event tick, you are constantly upgrading the ground distance. So just wanted to add this optimization. Check is on ground. So go for a sequence node and we will check if you are not on ground, then only we will update this distance. So this will save you a lot of resources. I almost forgot when I was implementing this. Let's connect this here, and this should be false pin, not the true pin. So if you are not moving on ground, that means you are falling or jumping, then only we will update this ground distance. Okay, now let's go back to our logic. So again, what I'm about to do is just for explanation. Now we will implement this in the weapon blueprint, but let's understand. So I want you to take a closer look at this Resident Evil 4 image. Do you see this aim line and how that red dot is appearing when you are pointing at the gate that is breakable? So first thing I want you to understand how the aiming system works is that this is a line that detects are there any items in this exact direction from where it is begun. So this is our starting position. Okay, the ray starts from here, and then there is something called as forward vector. Forward vector is the vector that gives you the direction, exact direction in which you have to start projecting the ray. How do we get that forward vector is by going in the viewport. Do you see this mesh has this forward vector, the arrow component? So the facing direction is the forward vector. So this is the direction in which we want to project the ray. Remember, the forward vector or the direction vector can be rotated by adding an offset. That means, let's say if the direction vector is at, let's say 90 degrees, you can add 10 degrees into it and it will shift by 10 degrees, and therefore it will be projecting at 100 degrees, not at the 90, because you just added. So this is a simple way to understand that you can update or modify the direction in which you want to project this line. Now, why do we need this line is because your character cannot go and check with the box collider that you have here, because that is what detects the actors and players and all that in your game, whether you have collided with something or not. So instead of going there by yourself, you project a ray that goes on your behalf and checks what is the first object that I have hit. Now this point is also determined by you. How far do you want your ray to go? So if there is no breakable object in between, it will go up to its endpoint, which you will specify. Okay, so let me quickly add the node so that you can understand. So I'll add a line trace by channel. So this is what will draw this line for us from the start position to the end position, just like this one. Now we need to provide the start position. Now if you come to your level in the third person blueprint, just drag this guy here. Now see, this is how your character will look like when you are in the game. Forget about this camera. This is just for capturing this character so that we can display on the inventory. This is the main camera that we want to focus on. So when you play, your crosshair is relative to the camera, not the character. So we cannot start that tracing from our weapon. We have to start from the camera. Why? Because it's the camera that shows you the game, not the character's mesh or his eyes. It's the camera. So the crosshair that you are going to use in the game is relative to this camera, not with this mesh. So we will project the line from this camera so that it aligns with your crosshair, not from the character. Now you might be getting this question, how does this is happening? So this trace is a different, it's for your visual purpose, but this is not the actual line trace that you see like this one. So what is happening in Resident Evil 4? When the ray is projected, you know the coordinates because this is the start and you will give the end. Now what you will do, you will just do the same thing again, but you will not change the end position, you will just change the start position, and rest, the path will be determined by the facing direction of the weapon. So this is our weapon. Now weapon will be projecting like this, but the ending point is what decides how the path will go. So we will change the endpoint to the point that is being calculated by the camera. Okay, if this feels like slipping out of your head, just rewind. Otherwise, you will understand once I will put this in the game. So for now, let's keep this player and I'll go in the third person character. I'll provide the start position. So to get the start position, we need to get the player camera manager. So the player index is 0 and then we will get the world location. Why we did the world location is because the line trace is relative to the world, not to your character. So we need to give the world location so that this can start the projection from that world location. So now this is the start position. Now we need the facing direction of this camera, or I must say the forward vector, which will be this line that you see, red one. So to get this, I'll get the forward vector. So this function allows you to get the facing direction of any actor. It could be a player, objects, gates, building, vehicle, anything. This will give you the direction vector or the forward vector. We will just multiply it by a single float. I'll change this to single precision and I'll say 2, and I will add this because we want to start from here and from here to how much distance you want to travel. So we will be taking that from this forward vector multiplied by 2. We will add it and this is the end position. Now if I play, I don't see anything. So for this, we use something called as draw debug type. So this helps developer to trace the line, whether it is working as per their requirement or not. If you do one frame, it will draw one line per frame. And let's increase it to 20. Play again. Now, do you see this red line? Once the frame is gone, the line will also gone. So to see the lines from all the frames that passed away and that are happening, you make it persistent. So if you do persistent, your lines from the old frame will stay there. So now if you see in the back, do you see I was standing there and my camera was just right behind me, and this is how the trace was working. Okay, I know it looks weird, but all I'm trying to say is that I'm standing here. Now the camera is in my back. If I just move, do you see this line? So this is how the trace is working. Now the next question arises, how far do we want to go? So for now, let's keep it. So now I can make it for one frame so that the lines disappear once the frame is passed. Now you see, so this is the way you can debug. Now once this line hits something, it will give you the result and it will not go any further. To check what we hit, so let's just split this and this give you all the details. Which bone you hit, which actor did you hit, what's the material and the hit location, how much distance is it, and all that stuff. Okay, so for now we just want to know what is the actor name. So we'll just connect this and it will use a function automatically to get the name of that actor. So the name of the actor is this BP third person character, or it could be anything depending on what the ray is hitting. So if I play now, you see it says SM ramp. Point towards sky, you see nothing. If you point towards character, you see it is not detecting the character. It is just detecting the floor and the ramp. So the reason is their collision settings doesn't allow this visibility channel. So what we'll do, we'll go to this capsule component, which is what detects all the collisions for us. In the collision presets, you can expand, change it to custom. Make sure this visibility, which is ignored, is switched to block. This means the ray trace that will hit this collider will be blocked and it will be considered as a hit. If you compile and play, and now if you hit that character, you can see it is saying BP third person character. Now let's say if I spawn the bullet by spawn actor from class and I say bullet, and now what would be the starting position of this bullet? We want the starting position of bullet to be our muzzle. So how do we locate that muzzle? If you open the pistol mesh, skeletal mesh, in the skeleton tree, you will find this muzzle socket that is placed exactly at the barrel position. This is where we want to spawn our bullet, but that should only happen if we hit something. So first I'll just remove this. I'll use a branch node and we will say this. So if there was a hit, then only we spawn the bullet. Now the bullet position would be equipment item. Then we get child actor, cast to B weapon, and then we connect it here, connect this one here. Now this equipped item child actor is just an actor. We need to tell Unreal that this is a weapon, so please give us the weapon object so that we can access its functions, events and variables. So what I want is inside my B weapon, I have this skeletal mesh. So I can rename it to weapon mesh. Compile, go back, and I want to access this weapon mesh. So I'll get this. Now once you receive this, you can access the socket. So to get the socket, you use get socket transform. This gives you the location, rotation and scale. If you split, you will see all three. But first we need to tell the socket name. So that is our muzzle. Remember, it's case sensitive, so please be careful with that. Now why we are not dealing with the cast fail? So let's say if due to any reason it's some other item which is not of type B weapon, then the bullet will not be spawned. It may be just a key that you are holding. So in that case, this will just not work even if you press left click. Now we have the location. That's what we want. So I will split this and I'll say this is the location where I want to spawn this bullet. Now we need to connect this logic with our fire button. So what I'll do, from the weapon graph, I'll just cut this just for now. I'll expand it and I'll just plug the started pin. Okay. If I pass it in trigger, then it will keep spawning the bullets. That is not something we want. If I press 1 now, and now if I press fire, you can see it exactly spawned at my gun point. Cool, this works. So how do we give the direction? Because this result that we got from line trace by channel was from the camera component, but we want this to begin on our gun point. So what we will do, we know what we hit. So we will use this hit impact point and we will just create another line trace that will start from the gun point, that is our muzzle, and it will go to this endpoint that we have. So before spawning the bullet, we will again create a line trace by channel. This is the socket location. So I'll plug it here. Now we can remove this branch node because even if you don't hit something, you should be allowed to fire. We need to remove this now. And now there are two situations we have opened. First is that there is an object that we have to hit, or if there is no object in the entire path, then we just consider the last endpoint of this trace, which is this one. So we will create a select node and we will recombine this pin and we will break it so that we have minimal options that we need. First, we will check whether we hit something. If we did hit something, then we will go for impact point. And if we didn't, then we will just go up to the trace end. Okay, and now you can collapse this. Now this is the end position. So what you can do is just pass it here. Now if there was a target, then this line trace will also give you the value. But this time we have to take care of the direction so that bullets exactly travel through that path. So for this, we will just break this. Now again, we have to do the same thing. We can copy these two nodes and paste them here, and you can remove this one, connect it with this. Okay, and now this is the end position from which we will subtract, and the starting position is the one where our muzzle is. Okay, so it is like calculating a distance, end minus the source. Once we have this distance vector, we will make rotation. So we will use rotation from X because we have to travel in the X direction. Now this X direction can be little downwards, upwards. What I mean by that is if I do like this, go W, this X is pointing in the upward direction. So overall, it's the X direction which we have to use for determining this angle. Okay, so I'll go to event graph. We made the rotation from X. Once we have this, we will tell this is our rotation. So this will spawn the bullet and it will spawn the bullet with that alignment. Now if I play, press 1. Do you see it exactly spawned at that location? Now the size is too big, so I'll go in the ammunition, bullet. In the viewport, we will reduce its scale to 0.25. So lock it. Remember, we are reducing it by box collider. So this will automatically reduce the size of the mesh without changing its actual values. Okay. Now you compile and play. Press 1, shoot. You see the bullet is exactly spawned at the position. Take this camera with you, press W and press E. Now you must be wondering, if I place this camera here, the trace will begin from here. Then you are thinking wrong, because the camera boom is still at the same position. We have just moved this camera, which is just the child. So remember, it's the camera boom that is giving us the location, not this follow camera. Whatever position that you set in the child is relative to its parent. It has nothing to do with the world position directly. Now if you play, press 1, shoot. Now we can take care of this size and all that, but overall idea is it is starting exactly from the muzzle. If I shift to my gun. Alright, now we are good. We can just set it to 0, 0, 2. Now all this is good. So I'll open this B weapon, okay, and I want my logic to reside here. So I'll create a function fire. And what we will do is just go in the event graph, and you can cut this entire logic except this action and go to the weapons, weapon blueprint. We will paste it here and we can now connect this, save all. We can get rid of this sequence node. Now we don't need it. And now we don't need this equipped item and B cast weapon because we have direct access to the weapon mesh. So let's get rid of this. This too, you can directly connect. You can use this weapon mesh here. So that's why it is better to keep logics modular and to their respective places. There's one more thing that you can do. Instead of having 3 lines like this, you can just break it, promote it to a local variable, muzzle position. Okay, and this is something that you can set right here. So I'll connect this one here and drag it on top. Okay, now you can use this muzzle position here, and then you can retrieve it, plug it here, and then here. Okay, so I've just beautified things a bit, and now you can compile, save all. My editor just crashed twice, so just wanted to make sure I'm doing it right. I'll delete this, compile it, go in the weapon graph, actions. So from actions, I can just drag it again. And now to access that weapon blueprint, we will just store a reference, equipped weapon, and we will change it to be weapon object reference. Okay, so I'll go to my inventory graph where I have this 1 and 2 logic, and I'll delete this old thing that we did. So for now, we are not handling unequip or equip. As soon as you equip, we will set that weapon here. We are not handling that case right now because I think video is getting too long. So what I'm saying is, if you press 1, I will assume that you have equipped the weapon. So we will just set the equipped weapon, get the equipped item, child actor, and we will cast to be weapon and plug it here, save it here. Why I did this here and not here is because if you keep pressing on fire button, I have to cast this actor again and again. Now I don't need to cast it again and again because I know you are holding the weapon, so I can just do it once, and if you unequip, I will just set it to none back. I don't have to cast and check repeatedly. So that's the reason we did it here. And now you can just copy this and paste it here and do the same for your shotgun. And now we assume when you will equip, this will have the weapon object reference. I'll go to weapon graph and I'll get this equipped weapon and I will call the fire and I'll plug this here. But there's a mistake. If you are not equipped, then this should not be called. So in that case, this equipped weapon will be none. So what do we do is we will check if it is valid. So if this is valid, then only do the fire. Otherwise, don't, because then it will throw an error. Let's give it a shot. If I play, click on it, fire, and now if you escape, you see I pressed 7 times, 7 times, and it showed me error. Access none trying to read property equipped weapon. The fire event wants this target. So we will plug this here again. Play now, click it, escape, you won't see the error. Now you can equip your gun and now you can shoot. Shoot. Okay, so before I end this tutorial, I really want to show you how you can add the motion in the bullet. So add, search for projectile movement. This will allow you to make your actor move with a certain speed. So the speed you can set 4000 for now and max speed 2, and the rotation should follow the the velocity, it should remain vertical, and let's not gravity affect our bullet. Okay, once you are done, just to compile, play, press 1 or 2, shoot. Alright, I hope you enjoyed this episode. In the next episode, we are going to add the dynamics, and I'm going to show you how you can break these mesh or barrels that we have created. So you will fire the bullet, these will break. You can even kill the characters also. Next video's primary focus will be on how you can make a mesh destructible so that you can hit it or drop it or throw it so that it breaks into pieces. So stay tuned, like the video, share it with your friends, subscribe to the channel, join the Discord community because we are getting a lot of new members. If you have any questions, doubts or struggles in the tutorials or episodes, feel free to comment down in the YouTube comments. And if you want personal one-to-one help, always feel free to post in Discord channel. I'll be happy to help you guys. Alright, so stay tuned and I'll see you in the next episode. Bye.